If it is including, we need to use this sign. The sign here is the signs of not including. The way we want to represent. Right. This is the linear inequality. Let's say quadratic inequality. We go to the second part about quadratic inequality. One inequality, x squared less than or equal to 5x minus 6. X squared. This is quadratic. I remember that when we study equation, types of when the highest power of x is 2, we call it quadratic. Now we talk about inequality, not about equations. So we want to solve and we want to find what's supposed to be in interval notations which represent x. Right. So first of all, what we have to do is we have to make our right-hand side is 0. We don't want, we have something on our right-hand side. So how to make that our right-hand side is equal to 0? How to make that? How to make that our right-hand side equal to 0? Can you think?
Transfer all the number to the left.
Okay. So x squared minus 5x plus 6 less than or equal to 0. All the numbers. Now we bring into left. Now we can factorize x squared minus 5x plus 6 to be x minus 2, x minus 3 less than or equal to 0. And now up until here, what we need to do is we have to find the critical numbers because we want to sketch sign diagram. So we need critical numbers. How to find critical numbers? Make all the terms is 0. Make x minus 2 equal to 0. X is equal to 2. 1. Critical numbers. Another one, make x minus 3 equal to 0. X equal to 3. Another critical numbers. So 2 critical numbers we have here. 2 and 3. Now we sketch sign diagram with critical numbers 2, 3. Sign diagram, we want to test for x minus 2, you want to test for x minus 3, and we want to find the resulting sign. So we test for x minus 2. And we want to test for x minus 3. And we want to know the resulting sign. What's happened? So our critical numbers, 2, 3. Okay. Now, imagine that the top of line here is a number line. So, all the numbers here must be what? All the numbers here. If you imagine this is a number line. So, all the numbers here, what must be what?
Less than,
Huh?
less than
Less than 2. So, we select one number which is less than 2. We substitute what we're going to have. What we're going to have. Substitute one number which is less than 2. Substitute here. We substitute here in terms of x. In the place of x, we substitute. So what we're going to have? The first one for case of x minus 3. What we're going to have? What number we're going to have?
1.
1. 1. 1.
So sir, if we substitute 1, all the result we get a negative number.
Negative 1. Negative number. Here?
Negative,
Negative 2.
Negative number as well. When negative multiply with negative, positive. Okay. Here meaning that we take one number which is in between 2 and 3. Take one number. Whatever the number between 2 and 3.
2.5.
2.5 for instance. Substitute it in terms of x. The first one.
Positive.
Positive sign.
Negative.
Negative sign. Negative. One number which is greater than 3.
4.
4.
Positive.
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 And definitely positive. So we have our resulting sign, positive, negative, positive. So which one we're going to choose? We look back at the original of inequality, which is less than or equal to 0, meaning that the negative number. The reasons you may ask why we choose negative instead of positive. Yes, because our original inequality is negative. Our original inequality is negative. So negative number. Right. Remember that when we talk about inequality, answer is not exact answer. It's the same like the equation answer in terms of interval notations. Therefore, solutions here will be what? From where to where? From where to where? If you look at the previous one, the solution is from minus to arbitrary until infinity. For this case,
between 2 and 3, sir.
Between 2 and 3, right? But we need to make sure that whether we close or open bracket, right? 2 is that including 2. You have to look at the sign here. Sign here means sign of include. Sign here is sign of include. Meaning that if we read, it does mean that the value of x must be located between 2 and 3 and must be including both of them. That's the solutions.
Sir,
Yes.
I have a question. What are we actually trying to do with the timetable? I mean,
Sign table, you mean?
yeah, what is that actually?
What sign table is to see where is the locations of our solution. Where is the location of our solution? And sign table is become compulsory here. No, because we have mark for this time sign table.
All right, sir.
Ah.
I understand.
Ah.
Thank you, sir.
So make sure that you familiar with this. Even though I know that we have another steps, maybe you learn in school, step using graph. That one I'm not quite familiar, right? Using graph. Also you can have, but here we need this sign table. The method of graph also can. I'm not familiar, but it's like this. 2, 3. But here, sign tables, and because of sign tables, we have mark there. I think mark here for critical numbers. Mark here also for the sign, for the resulting sign. Depends. That's why important to understand this sign table. Please try to understand why minus, plus, plus. The way you answer show that you understand why here minus, plus, plus. And at the end, after we draw sign table, at the end we have to look at the resulting sign. So in our resulting sign, we have plus, minus. Which one we want to choose? Look. And remember that if you look at this timetable, it is alternate between plus and minus. Plus, minus, plus, minus. But not always. Some of the timetables, some of the sign tables, plus and plus again. Or minus and minus again. Depends. Depends on the case. Depends on the case. So you cannot just, that's why mathematics is not the memorization subject. You cannot memorize. Today, they have tables. Later you can see different sign tables. Different number here, different sign there. You cannot say it is different. Yes, it is different. Definitely it is different. But why is it different? Because you follow the steps. Right.
Sir,
So sign table important for you to understand, right?
sir, I have a question.
Okay.
I can understand the second column of the timetable.
Second column. Here, you mean?
Yeah, plus and minus.
Okay. You take one value between 2 and 3. Between 2 and 3, we have several numbers. Let's say we take 2.5, let's say. We can take 2.1 or 2.2. You substitute into x. What do you have? 2.5 minus 2, positive number. Then you substitute into x, 2.5 minus 3, negative number. When positive meets negative, when multiplication, I read that here, multiplications between positive and negative. Why we need to multiply? Because multiplication here. In some more cases, not multiplications, maybe division. Depends on the inequality there. But at the moment we look at the quadratic, which is definitely multiplication. When plus multiply with minus, minus.
Yes, sir. Thank you.
Okay. So please bear in mind that between number 2 and number 3, we have several numbers here. When we talk about real numbers, definitely we have several numbers, not just 2 straight to 3, because we have several numbers when we talk about real numbers, 2.1, 2.2, 2.3. Then at the end, you look at the resulting sign. Right. Now we look at the inequality of rational when involved of the fraction. Rational is when involved of the fraction. For instance, solve the inequality 1 plus x over 1 minus x greater than or equal to 1. That inequality. So what we do, same like before, same like when we want to solve the inequality quadratic. We make that our right hand side 0. So 1 plus x over 1 minus x minus 1 is greater than or equal to 0. Right. 1 here, because we want to make the operations of subtractions between 1 plus x and 1 minus x with 1. So we change 1 here to be 1 minus x over 1 minus x. Why we change to 1 minus x over 1 minus x? Because we want denominator same. Denominator now is 1 minus x. Without making same denominator, we cannot perform the operation of subtraction. So to perform the operations of subtraction, we need to change 1 into 1 minus x over 1 minus x. In fact, it is 1. Right. Now we try to solve our numerator. 1 plus x minus 1 plus x, because minus and minus. Is that clear? Hopefully that you know that because of minus and minus. Minus 1 is like same like this. Look like this. We have a bracket there. Greater than or equal to 0. Can you see?
Yes.
1 minus 1, finish. X plus x to x over 1 minus x greater than 0. become like that. Or rational inequality. Right. Now, up until here, same like the quadratic inequality, we find critical numbers. Critical numbers. So 2x equal to 0. Make it is equal to 0. 2x equal to 0. X 0. Another one. 1 minus x equal to 0. X 1. So we have two critical numbers, 0 and 1. Okay. Imagine that number line 0, 1. We want to test for 2x. We want to test for 1 minus x and the resulting sign. To x, 1 minus x, resulting sign. Take one value which is less than 0. Right? Left of 0 meaning that less than 0.
-1.
Substitute. What do you have?
Negative.
And then
Positive.
Positive.
Now divide. Minus divide by plus.
Negative.
Between 0 and 1.
Positive.
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 More than 1. Positive.
Positive. Negative.
Negative. Negative.
Negative.
Right. So we have our resulting sign is minus, plus, minus. Now choose. We need to remember that the original is greater than 0. Greater meaning that we choose plus. Greater than we choose plus. If you remember that the previous examples, we choose minus. But now we choose plus, but that's not matter. Not always when we say minus before, minus again here. No. Sometimes we choose plus, sometimes we choose minus. Depends. Depends on the situation. Depends on the what we want to solve. So solutions must be in terms of interval notation as well. So solutions here between what? Between what?
0 and 1.
0 and 1. Okay. Between 0 and 1. So is that including 0?
Yes.
Yes. Is that including 1?
Yes.
No.
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 Big.
The reasons why cannot we include 1, because for the case of fraction, for the case of rational, same like equations, that we have to check. When we substitute 1 here, so our denominator become 0. We do not want denominator 0. If denominator 0, it is undefined. So 1 must be excluded. Similar as well, if you solve the problems regarding equations of rational. These rational are fractions. So, you know now by why we need to exclude 1. So, if you look at the previous examples, because previous examples only for quadratic, we don't have denominator. In this case, we have denominator. For the case of rational, we have denominator. Therefore, we have to be careful. Seems like when you solve the question of equations, you have to check. When solve question of equation, before we go to inequality, equation were involved of radicals, equation when involved of rational or fractions, we have to check. So the answer or the final solution is all the numbers between 0 to 1 and including 0 but not including 1. Right.
Sir,
Yes.
I still don't understand how do we want to including 0 and how to including 1, 0 and 1 or not including 1.
Okay. We include 0 because the sign here is the sign of including. Okay. We want to include 1 as well. Because the sign of including. But when we include 1, our original inequality denominator become 0. So we want to avoid this to happen. To avoid this to happen is by excluding 1. So only 1 we exclude. Remember that from 0 to 1, we have several numbers. We have to bear in our mind that we have numbers. When we talk about mathematics, for mathematicians, between 0 and 1, we have several numbers. For non-mathematicians, I don't know. For non-mathematicians, between 0 and 1, after 0, straight 1. But here we have to remember that. Let's say 0 here. 1 here. So number which we read is starting from 0. Starting here. We read all the numbers we read, and we need to stop before it's reaching 1. This is that mean. Before it's reached 1, we have to stop. Maybe the point where we stop is 0.99999, etc. But as long as it is not 1, that it does mean that by this. So we have to bear in mind, now you have to change your mind to think that we have lot of numbers again, right? When we talk number of 0, 1, 2, 3, 4, 5, 6, in between this we have lot of numbers.
Thank you, sir.
When we talk about real numbers. And now we go to inequality for absolute value. And for the case of inequality for absolute value, you need to remember, or you need to refer to properties of absolute value for inequality. Properties of absolute value for inequality, you can refer to books. You can refer to whatever books if you don't have book yet. If you can refer to books for SDPM, or you can refer to books for matriculations, or whatever books, as long as you have properties of inequality of absolute value. Perhaps maybe the books in SPM, I don't know, I'm not quite sure whether you study during SPMs or not, of absolute value inequality, but for properties of them. Let's say we want to solve this. Absolute value x plus 2 over 2x minus 1 greater than or equal to 3. X plus 2 over 2x minus 1 greater than or equal to 3. For the case of properties of absolute value, it does mean that we can separate into two parts. When you look at the properties of absolute value, first part is the parts of x plus 2 over 2x minus 1 greater than or equal to 3, or another part is x plus 2 over 2x minus 1 less than or equal to minus 3. How do we get this? You refer to the properties of absolute value. Properties of absolute value for inequality. Either x plus 2 over 2x minus 1 greater than 3, or x plus 2 over 2x minus 1 less than minus 3. For the case of absolute value, x plus 2 over 2x minus 1 greater than or equal to 3. And now we need to solve one by one. We need to solve left and we need to solve right. We need to solve one by one. Left hand side, right hand side. Right. Now, let's say we solve left first. Oh, you can solve right first, does not matter. Let's say we solve right first. We solve left first. We solve left. So, this inequality, we want to make the right-hand side of this inequality is 0. So what we have to do is x plus 2 over to x minus 1 minus 3 greater than or equal to 0. Now, we cannot perform the operations. Only we can perform that operations by making denominator 2x minus 1 for both. So we want to make denominator as 2x minus 1. X plus 2 remain, that minus 3. 3 must be multiplied by 2x minus 1 greater than or equal to 0. This is our left hand side. Hopefully that you noted here why we multiply by 2x minus 1, because we multiply both numerator and denominator with 2x minus 1. So what do we have here is x plus 2 minus 6x plus 3 over 2x minus 1 greater than or equal to 0. Right. So x minus 6x minus 5x 2 plus 3 plus 5 over 2x minus 1 greater than or equal to 0. Right. X minus 6x minus 5x 2 plus 3 5. So we have critical numbers. Critical numbers we have x is what? X is what? Our critical numbers. X is what?
One over two, sir.
1 over 2. 1 over 2. Another one?
0.
Huh?
0.
0.
1.
Yeah.
1.
Negative 1.
Negative 1.
Minus 1.
What?
1.
Negative 1.
1.
1, right?
1.
So critical numbers 1 over 2 and 1. 1 we get from numerator. 1 over 2 we get from denominator. So we make sign diagram. 1 over 2, 1. Okay. Minus 5x plus 5. 2x minus 1. Resulting sign. Minus 5x plus 5. x minus 1. Take one value which is less than 1 over 2. Less than 1 over 2.
0.
0, let's say. Substitute. What do you have?
Positive.
Yeah?
Negative.
So
Negative.
that negative. Between 1 over 2 and 1. One number between 1 over 2 and 1. Whatever the number, as long as located between 1 over 2 and 1.
3 over 4.
3 over 4, let's say. Substitute.
Positive.
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 Positive. So
Positive.
greater than 1.
Negative.
Negative.
Positive.
Positive. Negative.
Negative.
So which one we choose? Look, the sign.
Positive. Positive.
This one. So solution for left. Not the whole solutions yet. Not the final solutions. Because this is the solution only for left, because we don't go for right yet. Solutions for left is all the numbers between what? Between what?
1 over 2.
1 over 2 and 1. Right. Now, is that including 1 over 2?
No.
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 Excluded.
Exclude 1 over 2. Is that including 1?
Yes.
That's from our left. Only solutions for our left, not the final solutions yet. Now we go to our right. Same like when we solve for left. X plus 2, 2x minus 1 plus 3 less than or equal to 0. By bring minus 3 into left hand side. So x plus 2 plus 3, we want to make denominator to x minus 1. So 3 must be multiplied by 2x minus 1 less than or equal to 0. We want to make the same denominator. So 3 here must be multiplied by 2x minus 1. Same like this. 2x minus 1, sorry, 2x minus 1. 2x minus 1. Same like this. Right. So take a break and come back at 9 o'clock. Right. Come back at 9 o'clock. Right. Take a break. Maybe some of you want to go to the toilet or want to take a rest. And come back at 9 o'clock. Right. Okay.
All right, sir.
Okay.
All right, sir.
less than or equal to 0. Less than or equal to 0. Right. Now, our right, critical numbers in our right, x equal to what? Critical numbers in our right.
1/2.
1/7.
1/7 and
1/2.
1/7, 1/2. 1/7 left of 1/2 because it's smaller. 1/7 is smaller than 1/2. Um, 7x minus 1, 2x minus 1, resulting sign. The first one, I take one value, negative. And
Negative.
negative. Positive. Negative divided by negative, positive. 1/7 and 1/2, between 1/7 and 1/2, take one value, substitute. What do you have?
Positive.
Positive,
Negative.
negative,
Negative.
negative. More than 1/2,
Positive.
All positive.
positive,
Positive.
positive,
Positive.
positive. Now, which one we want to select? We have positive, negative, positive.
Negative.
Look at the sign. The sign here is less, negative. So, solutions for right is from where to where? From where to where?
1/7,
1/2.
1/7, 1/2. Is that including 1/7?
No.
Yes.
Yes.
Yes,
Yes.
yes.
1/2?
No.
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 Right. Now we have solutions on left and a solution on right. Since O here, O, must be the final solution is the union between these solutions. So, final solutions. This is the solution for exactly solution. Solution. This is not the solution for left, solution for both. Must be union with of these two. Must be from 1/7 until 1/2, union with 1/2 until 1. We write 1/7 until 1/2 first. We always write smaller first. Smaller and then greater. Smaller is 1/7 until 1/2. Union with 1/2 until 1. I remember that because this is the case of O. But for the case of AND, you need to find the place of intersections. For the case of O, union, which means that you take all those solutions. But for the case of AND here, where the case of AND happen when it is less than. This is the properties of absolute value inequality. That's why I said to you to refer to the properties of absolute value inequality. So this is the last solutions. Last solutions, which consists of both left and right. And we do the union of the solutions because, if not, no, we have to find the place of intersections. We have to find the place of intersection for the case of AND. Okay. Since many people ask me that tutorial 1, I put in your Google Classroom, right? The day or the time you need to submit that tutorial 1, I will let you know. At the moment, not yet. Even maybe some of the questions in the tutorial 1 you cannot answer yet. Because maybe we didn't study yet for that part. And the part you already study, you can solve, right? But only later you submit to me the tutorial 1. I will tell you the date you need to hand in to me. Right. So at the moment, your job is you just solve. Just solve the tutorial and keep. Just solve, because maybe you need to, we have to wait, right? After finish chapter 1, right? Because not all the questions you maybe can answer yet. But the one you can answer, you can do. So please, like I told you in the first day, that the day and time for the tutorial to submit to me, I will let you know. Since no news about that, I just gave you the question of tutorial. But for you to try, right? Not to submit yet, right? When times come to submit, that's I tell you. And I will tell you in advance. Not meaning that I want to tell you today, then I want you to submit tomorrow. No. You must have times to complete that. So, because of that tutorial consists of many questions, you can do gradually. What we say gradually. So you do little bit by little bit by little bit. Let's say after finish of the part of inequality, you can do question of inequality. After this complex number, you can do question of complex number. You do until I say to you, yes, time to submit tutorial 1 must be submit before that time, before the day, that time. I will tell you. And definitely, I will tell you not in advance. Right. Please, just to tell you in advance, do not worry. Please do not worry. So, yeah, now that you just calm and relax. I don't want to press you because I know that apart from mathematics, also you study another subjects, right? So you just come, especially during the times now, hard times now, hard times, the times of the pandemic now, hard times, right? So you just relax. Not to relax, but relax, calm down and relax, calm down. The time that you need to submit, yes, you submit. I tell you in advance to submit. I told you on the first day, and remember that for tutorial, for open book test and quiz, that's different. We'll give you during the lesson. For open book test, we'll give you during the lesson time, and then you answer during the lesson time and you submit. For quiz, we're going to have math quiz that I told you last time. Friday night. Right. Is that I told you before? Friday night. Friday night for that particular week. Not always Friday night. Not meaning that tomorrow is Friday, tomorrow night, no, it's quiz. No. Friday night on that particular week. Which week? You can refer to teaching plan. The week that we have quiz. So the Friday night for that week, yes, we're going to have quiz. Unless any change. I will let you know as well. If change, we'll let you know. If no change, remain like that. Okay. Right. Now, this back to here. This inequality involved of the absolute value for the case of greater than, and because of the greater than, we have or. Why greater than or? You refer to the properties of inequality of absolute value, right? For the case of less than, it must be n here. And for the case of n, the final solution, you have to find the place of intersections, right? Right. Solve absolute value 4 minus 2x 3x plus 2 less than. This is the case of less than. before greater than. Right. Since now 2 here not involved of any unknown, not involved of any variables, right? Variables is here. 2 here not involved of variables, therefore we can multiply straight 2 with 3. So what we going to have is 1, 4 minus 2x, 3x plus 2 less than or equal to 6. 1 multiplied by 4x plus 2 over 3x plus 4x minus 2 over 3x plus 2. Same. So for x plus 2, in fact, this inequality is inequality of absolute value of 4 minus 2x over 3x plus 2 less than or equal to 6. When less than, when you refer to properties of absolute value, is going to be like this. Minus 6 less than 4 minus 2x over 3x plus 2 less than or equal to 6. Looks like this. If you remember that our previous example is greater than. Greater than is different. We have or. But less than, now we have and. And if we separate into 2 parts. One part is part of minus 6 less than 4 minus 2x over 3x plus 2. And another part is 4 minus 2x over 3x plus 2 less than 6. See the word and there. And now we solve. Same like before, we solve one by one, left and also right. Left. Now we talk about left. We have this. It can rewrite as 4 minus 2x, 3x plus 2 greater than or equal to minus 6. Same. Another way to write. It's same. So what we do is we want to make our right hand side as 0. So 4 minus 2x over 3x plus 2 plus 6 greater than or equal to 0. Plus 6 greater than or equal to 0. Same 4 minus 2x plus 6 times 3x plus 2. Denominator 3x plus 2 greater than or equal to 0. So what do we have is minus 2x plus 3 times 6 minus plus 16x 12 4 plus 12 plus 16. 16x plus 16 over 3x plus 2 greater than or equal to 0. Right. So critical numbers. X equal to what? What is our critical numbers? X equal to
1.
-1.
Negative 1.
minus 1, right? Minus
Negative.
1
Yes.
and
-2/3.
Negative 2 over
3.
minus 2/3. So minus 1 minus 2/3, 16x plus 16, 3x plus 2, resulting sign. This is 16x plus 16, 3x plus 2, resulting sign. Take one value, which is less than minus 1.
Negative.
If
Negative.
negative,
Positive.
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 Negative.
Negative. Negative.
Negative.
Positive.
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 Okay. Now, solution on left between minus 1 until minus 2/3. Right. Minus 1 include or not? Include or not minus 1?
Include, sir.
Yes.
Include.
Include. Minus 2/3?
Yes, sir. Include.
Include, sir.
No.
No,
No, sir.
must be exclude because
No.
look back here, right? So it's going to be 0, must be exclude. Right. Now we go to our right. This is our right. Our right. Okay. 4 minus 2x, 3x plus 2 minus 6 less than or equal to 0. So 4 minus 2x minus 6 times 3x plus 2 over 3x plus 2 less than or equal to 0. Right. So what we get is minus 2x minus 18 minus 20x. 4 minus 12. 4 minus 12 minus 8 over 3x plus 2 less than or equal to 0. You get it? So the critical numbers x equal to
Negative 2 over 5.
minus 2 over 5, and another one minus 2 over 3, right? Minus 2 over 3, another one.
Yes, minus 2 over 3.
Okay, so now construct sign diagram with minus 2 over 3 first, and then minus 2 over 5. Right. Okay. Here minus 20 x minus 8. Right. 3x plus 2 resulting sign. Any questions so far? Any problems? No problems.
No, sir.
And now you substitute. Substitute one value which is less than minus 2 over 3. You substitute here. What do you have?
Positive.
Positive.
Negative.
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 Positive.
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 Positive. Positive.
Negative.
Negative.
Positive.
Positive.
Negative.
Negative. So which one we choose here? Which one we choose?
Negative.
Negative. So solutions for right, we have two parts. One part from minus infinity until minus 2 over 3, not including this part, this negative. Union with this part. Minus 2 over 5, which is include, until infinity. So here I think it's wrong. Because sign is plus, so we have to choose plus. Solution minus infinity until minus 1 union with minus 2 over 3 until infinity. Right. Instead of negative, because we choose negative before, we're supposed to choose positive. Because greater than. Can you see? Can you see why we change here? Because we're supposed to choose positive, not negative. And that's the solution for left and solution for right. And remember, because the word and there. So we have to find the place of intersection. So how to find the place of intersection between these two solutions? We draw one number line. Okay. And we write down all those values. Start with minus 1, because minus 1 is the smallest. Right, and then minus 2 over 3, and then minus 2 over 5. Okay. From negative infinity until 1, this is a sign of including. From negative infinity until 1, this one. When we represent in number line, from negative infinity until minus 1, union with from minus 2 over 3, which is not including, this is a sign of not including, until infinity. And that's from our left. From our right, from negative infinity until minus 2 over 3, not including this one. Minus infinity until minus 2 over 3, union with minus 2 over 5 until infinity. This one. Minus 2 over 5 until infinity. Right. So where they intersect? They intersect only this part. And this part. Apart from that, no intersections. No intersections. Apart from that, no intersections. So, final solution. Now, when we talk about when case of n here, n is more complicated. So, final solution only for the case of they intersect, which is from minus infinity until minus 1, including union with minus 2 over 5, which is including as well. Sorry, including. It's including sign of including. Including until infinity. This is the final solutions. For the case of end, we have to do a little bit because we need to find the place of intersections between left and right. But for the case of or, no. We just find the union. We take all the values of the solutions of left and all the values of the solutions of right. And if you look at these examples, the solutions here, plus, but we have a gap. But that's no matter because it's come from minus infinity until minus 1, union with from minus 2 over 3 until infinity. Similarly here, from minus infinity until minus 2 over 3, union with from minus 2 over 5 until infinity. And then we draw in number line to see clearly and to see the place they are going to intersect. Intersections of those we represent the final solutions, because the solution that we have so far up until here is only the solutions for left, and solutions up till until here is only for the solutions for right. So you have to be careful with the case of n. And when n it happens, normally when the value less than. There's one properties of absolute value of inequality. The one that you can refer. You can refer.
So I have a question.
Yes.
Why do we have to exclude the number infinity?
Have to exclude? Infinity always we exclude. Regardless whether it is negative infinity or positive infinity, we exclude. Bear in mind that infinity always we exclude.
Yes, sir. Thank you.
We have another examples. Inequality 1 over x minus x over 3 less than or equal to x squared plus 2x minus 3 over x. Now not involved of the absolute value. But you can see that here we have another fractions here. So what we do first, we try to make this as a single fractions. We try to make as a single fractions. So 1 minus x squared over x over 3 less than x squared plus 2x minus 3 over x. We change this into single fractions. 1 minus x squared over x. Hopefully that you know how to change 1 minus x squared over x. And if we want to change into only one fractions, we don't want fractions and then fractions again. So it is 1 minus x squared over 3x less than x squared plus 2x minus 3 over x. One minus x squared over 3x. This one where we change. Hopefully that you know how to change this. And this is basics. Basics of changing of that, which you're supposed to know before. And now, what we want is you want to make what? You want to make what? The next steps of our inequality. What we want to make? I will come up until here. What we have to do? What we have to do? We move 1 minus x squared over 3x minus x squared plus 2x minus 3 over x less than or equal to 0. Now,
Make the denominator same.
Ah. Right. So you try to solve this one. To solve that, you try supposed to get at the end your answer must be from minus 5/2 until 0 union with 1 until infinity. You're supposed to get that answer. Right, try to solve. I try to continue from here, and you're supposed to get this, right? Again, the tutorials, do not worry that you need to pass up, but not you need to pass up. Now you still, I will tell you the day that you have to pass up, right? So try to solve this. Inshallah, next lesson will be Monday next week. Right. So I stop sessions today with Tasbih Kifara and Surah Al-As.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes,
Together.